Hello everyone, we are a group under Engineer Jonathan Dundon and we are here to present our proposed thesis topic titled Design and Simulation of Improved Rice Husk Fired Furnace for Rabbit Fish Dryer. First of all, my name is Robic R. Macabalo and I will cover our thesis introduction. The demand for renewable energy has been steadily increasing for the past few years. Because of this, inventions such as the rice husk fired furnace, or RHFF, has been created which uses rice husk as a fuel source. In agricultural countries such as the Philippines, the rice husk is very abundant but is considered as a waste for local farmers. That is why through the utilization of the rice husk fired furnace, the rice husk, which is considered as a waste, can be turned into a renewable fuel source. It is also very important to mention that this topic is a follow-up study from Engineer Manzana's study titled Design, Fabrication, and Performance Evaluation of Hot Air Dryer Equipped with Rice Husk Fired Furnace and Cross-Flow Heat Exchanger for Rabbit Fish, which utilized the rice husk fired furnace in a system used to dry rabbit fishes in a more efficient manner. Next is a statement of the problem. The study by Engineer Joseph Manzana has an underlying problem which is the low efficiency of his design system. One of the causes for these low efficiencies will be the heat losses from the furnaces that was incorporated in the system as indicated by figure 1.2. We can see from this figure that the heat losses from the furnace that was incorporated in the drying system. We can see from the rear surface that 2004.81 watts of energy was lost, and from the right side and left side surface, 1968.569 watts of energy was lost. This problem needs to be studied in order to lessen the energy losses of the rice husk fired furnace, which in turn improves the overall efficiency of the system. Next is the objectives of the study. The main objective of the study is to design, simulate, and evaluate the performance of an improved rice husk fired furnace to reduce the heat loss of the furnace from the original design. Specifically, this study aims to number 1. Design and simulate an improved version of the rice husk fired furnace from the previous study using a simulation software called Autodesk Fusion 360. And number 2. Simulate the design of the rice husk fired furnace of the previous study. The importance of the second objective is so that we are able to conceptualize a design based from the results of the simulation. And number 3, to evaluate the performance of the improved version of the rice husk fired furnace and compare it with the simulated results of the previous study. Next, we have the significance of the study. The reason why our study or our topic is very important is because improving the overall efficiency of the drying system lessens the fuel needed to achieve the same energy output. This study also promotes the usage of the rice husk fired furnace along with the usage of the rice husk as another fuel source for heat energy, so that the rice husk will not be considered as a waste anymore. In addition to this, the improved design of the furnace may also be used for applications other than the drying of food, such as the heat treatment of various materials. Next, we have the scope and limitations. This study will only focus on the improving of the design aspect of the rice husk fired furnace through the use of a simulation software, namely Autodesk Fusion 360. The study only compares the simulated performance of the new and old furnace design. As said, It will only focus on the improvement of the furnace design aspects such as the structure and materials.
Greetings, I am Manahan, and these are the studies that the researchers found useful for the paper. So in this table, it is divided into 3 rows for researchers, title, and their type of study. So for Oyegbon and others, the type of study that they conducted were the following: design, fabrication, and simulation. For Komolafe and others, the type of study that they conducted was design and fabrication. For Raman, it is the same thing with Komolafe and others, which is design and fabrication as well. For Kalay, the type of study that they conducted were the following: design, fabrication, and evaluation. For Nor and others, the type of study that they conducted were design and simulation. Following Mirana and others, their type of studies were design and fabrication. For Hung and others, their type of study is also design and fabrication. For Bella and others, their type of studies were the following: design, fabrication, and comparative. For Myo and others, their type of study was design and evaluation. Lastly, one of the studies that we have is from Engineer Joseph Manzano's study, which is design, fabrication, and performance evaluation of hot air dryer equipped with rice fired furnace and cross flow heat exchanger for rabbit fish. And the type of study that he conducted were the following: design, fabrication, and performance evaluation. So this is the main focus or the main basis of the said paper. Thank you.
And now, let's proceed to the theoretical considerations. In this study, we define 5 different terms that might help in our simulation. The first 3 terms that we defined are the modes of heat transfer, which is the conduction, convection, and radiation. We chose these terms because it is the 3 main factors that affects heat transfer, which is related to our topic, which is increasing the efficiency of furnace. The first mode of heat transfer is conduction, which is the process by which heat or electricity is directly transmitted through a substance when there is a difference of temperature. It is defined by rate of heat conduction equals to negative of thermal conductivity times the temperature difference. The second mode of heat transfer is convection, which deals with the flow or movement of fluids to transfer the heat from one solid surface to another. It is defined by the equation as the rate of heat convection equals to the product of heat transfer coefficient and heat transfer area multiplied by the difference of surface temperature and the fluid temperature. The third mode of heat transfer is radiation, which is the transfer of heat through an electromagnetic wave. This mode of heat transfer does not depend on contacts between the heat source and the heated material. It is defined by the equation as the rate of heat radiation equals to the product of emissivity of the material surface, the Stefan-Boltzmann constant, the area of the surface, and the temperature of the surface.
Now let us proceed to the chapter 4, which is the methodology. In this study, there will be 3 phases in order to complete the activities needed for the study. The first phase will be the furnace design conceptualization, and it is consisted of 4 steps. The first step is to adopt the required values and design from the previous study. The study will adopt the formulas and values used in Engineer Manzano's paper, such as the calculation of heat loss, higher heating value of rice husk, and the mass of air required for the combustion of the rice husk. Second step is the simulation of previous design. In this step, the furnace designed by Engineer Manzano in his paper will be simulated for future comparison using Autodesk Fusion 360. The sketch of the furnace of Engineer Manzano is as shown. The third step is the previous design data analyzation. In this step, the researchers will analyze the data and decide how the heat loss from the furnace will be reduced. Fourth step is the test design conceptualization. The rice husk fired furnace test design will be conceptualized first by using the data obtained from the preceding furnace simulation and will be drawn in the Autodesk Fusion 360. Basically, in this step, this is where the initial proposed design will be presented. In the figure 4.2, the isometric view of the initial furnace design is shown. Here, we can see that the fan air inlet, the feeder, and the surface where the combustion will occur is present. In figure 4.3, we can see the inclination of the ash chamber covered by a metal sheet. It is covered so that there will be no loss in the air entering the furnace. In figure 4.4, the top view is shown. The width of the feeder is shown in this figure. Here in figure 4.5, the fan air inlet is shown, and in this design, it has a 14 cm diameter. In figure 4.6, the feeder inlet is shown. It is tapered with a 26.5-degree angle so that the rice husk entering will have a higher velocity. In figure 4.7, we can see the grates of the left side of the platform. It is where the air from the fan air inlet will enter. The grates will have a width of 1 mm. It is because a rice husk's typical dimension is 4 mm by 6 mm, and the most common being 2 and 3 mm below. Having a width of 1 mm will ensure that there will be no rice husk that will escape through the gates. The right side of the platform will be supported by a hinge, making it function like a trapdoor. In this way, it will be the outlet of the ashes of the burnt rice husk. Now let us proceed in phase 2. This phase will only contain 2 steps. Here in step 5, the researchers will consider the flaws of the design of the conceptualized design after running the simulation. It will be then improved and simulated to find the significant difference. In this step, the values gathered from the simulation of the previous study and the simulated design in step 5 will be gathered to supply data needed for phase 3. This is where the determination of the heat losses of the simulated designs will occur. In phase 3, there will be 3 steps in order for the researchers to evaluate the results. First is the data comparison of the previous and improved design. Basically, in this step, the data gathered from the previous and enhanced design will be compared. It will be the basis of investigation whether there is an improvement of efficiency of the furnace. The 8th step will be presentation of data. Here, a table will be used for the presentation of data so it can be easily understood by the reader and the researchers. The last step will be the analysis of data and interpretation. An overview of the factor helped to minimize heat losses around the furnace and increase performance will be achieved using these presented results. This analysis should define the relationship between the factors of the test. Analysis and interpretation will also include recommendations and ways for future studies to enhance the design.
For a better representation of our proposed schedule, the researchers utilize a Gantt chart. It will be the basis for the schedule of steps to finish the study. For Phase 1 or the furnace design conceptualization, it will be conducted from week 1 to week 3. For Phase 2 or the design simulation, it will be conducted from week 4 to week 8. And for Phase 3 or the evaluation of results, it will be conducted from week 9 to week 11. In the budget proposal, we only listed a device for simulation. It is an insert laptop model. This model was chosen because it met the minimum requirements for a computer to run a simulation on Autodesk Fusion 360. It will cost around 29,992 pesos. This is the end of the presentation of our study. Thank you and have a nice day.